All right, so one last type of transformation that we can apply to our parent functions here. We've translated, we've stretched and shrinked. Now we're going to reflect. We can reflect things across the x-axis and the y-axis. So let's take our parent points and reflect them. So what are you looking for in an equation when you're going to reflect? So basically a negative, not a minus sign, but a negative, or think about multiplying by a -1. When you are multiplying by a -1 somewhere in your equation, that's going to result in some type of reflection. And you've got basically two options. If you have or are multiplying by a -1 outside of the argument, for example, you've got your function and you've got a negative outside, that is going to reflect it across the y-axis. I'm sorry, it's going to reflect it across the x-axis because it's a change in your y values. So it's kind of sounds a little bit like it's the opposite of each other, but if you have a negative outside of the argument, you're actually changing your y values because anything outside of the argument affects y values. So if you affect your y values, negative versus positive, it's like reflecting it across the x-axis. On the flip side of that, if you have a negative inside the argument, so if you have a negative inside your square root or inside your square or your cube, that's going to reflect it across the y-axis because it's a change in the x values. And again, that seems kind of backwards, but if you flip over your x-axis, you're actually changing your y's. And if you flip or reflect across the y-axis, you're actually changing your x values. So let's see how this works. In the first one, we've got a squared function. So I'm going to make my table here. Again, you always have to start with your parent points for the squaring function. So that'd be -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now I've got a couple different changes here. I notice I have a negative outside the argument, and I have this -4 inside the argument. Now for me, I like to apply any changes to my x values first. Of course, any changes inside the argument are going to affect my x values. So inside, I see that I have a -4. Well, that's going to be a shift to the right 4 units. So that's like taking x and adding 4. So let's just do that right now. So -2 plus 4 is 2, 3, 4, 5, and 6. And then outside, I've got this negative. Again, anything outside is going to affect your y values. So if I have a negative, that's basically like a -1 outside. It's simply just like taking all your y's and multiplying by -1. So that would become -4, -1, 0, -1, -4. So these are going to be my new x values. These are going to be my new y values. So if I graph it, I get 2, -4, 3, -1, 4, 0, 5, 1, 6, -4. Now normally our parabola is opening upward, but because of that negative outside the argument, like it says above, a negative outside the argument reflects it across the x-axis. So it's kind of like it flipped over the x-axis, and that happened because I multiplied all my y values by a -1. Let's try the next example here. Again, I can see I've got two changes. That's a square root. So I'm going to put my square root parent points up, 0, 0, 1, 1, 4, 2. I notice I'm going to have two transformations. I notice I've got one inside the argument and I've got one outside the argument. I always start with inside the argument. So you've got a negative inside the argument. Anything inside affects your x's. So that's just like multiplying your x's by -1. So if we do that, that would still be 0. That would be -1 and -4. So that is a reflection across the y-axis. Here, you've got a shift up 4. So that would be like taking your y's and adding 4. So that would be 4, 5, and 6. So here we go, 0, 4, -1, 5, and -4, 6. So, like that. Again, since I had a negative inside the argument, that was a reflection across the y-axis. And again, if there's a negative inside, it's a reflection across the y-axis because I multiplied all my x's by -1. And you can see that square root graph is normally pointing towards positive infinity, now it's pointing towards negative infinity. So just like the last one, number 1, I had a negative outside, that was a reflection across the x-axis because I multiplied all of my y's by -1. So it's no different than we've done stretches and shrinks, we've done translations, now we're just throwing in that negative either inside or outside to cause that flip over one axis or another. One more example. Oh, that's a monster right there. A lot of stuff going on with that guy. So let's go through it. First, you got to recognize that you've got a squaring function, right? So we've got our squaring function. I see 3 transformations. I actually see 4 transformations. So I've got a negative outside and a -3 outside. I've got a -4 inside the argument, and I've got a +5 outside the argument. So what I've got going on is I've got a shift right 4 units. That's going to be this guy here. That's the only thing going on inside the argument. I've got a negative outside the argument. That's going to be a reflection across. Remember, outside the argument would reflect it across the x-axis. I've also got, so that's the negative piece, I've got this 3 outside. That's going to cause a vertical stretch of magnitude 3. And then I've also got this +5 outside. That's going to cause a shift up 5. So we got a lot of work here on this one. This is about as complicated as it gets. So first, it's a squared function, squaring function. We've got to have our parent points. Step 1 is just to put those parent points in. Next step, we've got a lot of different transformations. The question is, which one do I apply first? Well, I always do x's. If there's any change in x's, I like to do those first. We've only got one change in my x's, and that would be this shift to the right 4. That's the only change that's happening in the argument. Therefore, that's the only change that's occurring with your x's. So I'm going to add one more column here. If I am going to the right 4, it's like taking your x values and adding 4 to them. So that would be 2, 3, 4, 5, and 6. So that's it with the x's. Now I've got the y's. I've got 3 different transformations that change my y values. All I really need here, though, are 2 more columns. Because if you look, I am, with these 2, basically multiplying my y values by -3. And on this one, I'm basically just adding 5. Now, it is important which one you do first. if you've got a stretch or shrink and a translation, say with your y values, could be for your x as well, you always have to do the multiplying first. That goes back to just order of operations. You would always want to multiply before you add and subtract. So I'm going to multiply my y's by -3. And then I'm going to add the 5. That's very important. You can't add the 5 to y and then multiply it. So first thing I'm going to do is take my y's and multiply it by -3. So in my y column, I got 4 times -3, that's -12. 1 times -3, -3, and so on. Again, these are going to be my new x's right here, but now I have to go and take this column and still add 5 to them. So don't add 5 to your original y's, add 5 to your brand new stretched y's. So -12 plus 5, that's what we're doing now. -3 plus 5, we're taking this last column here and adding 5 to them. So that would be -7, that would be 3, whoops, that would be 2, that would be 5, that would be 2, and again, -7. So when we graph, we're going to have -12. So I've got my y's right here, and my new x's in that third column. So it's 2, -7. So 2, -7. I'm going to have 3, 2. I'm going to have 4, 5. 5, 2. And 6, -7. So you see it's flipped upside down. It opens down. That's from that reflection across the x-axis because I ended up multiplying outside by a negative. You see it has been stretched vertically. It's a little taller than normal. It also shifted up 5 and to the right 4. So that's about as complicated as an example as you guys are going to get with all of those different transformations in one. So that's kind of tying reflections and translations and stretching and shrinking all into one example.